This Equipment World video is brought to you by Chevron Delo 600 ADF Ultra Low Ash Diesel Engine Oil. It's time to kick some ash. Hi everyone, welcome back to Equipment World. My name is Brian and you're watching The Dirt, the video podcast that's geared towards bringing you news and discussions about new construction equipment and just general happenings in the construction industry. So this week's episode is actually a continuation from last week's episode where we were discussing 2D machine control and how it can benefit you as a contractor. Last week we were on with Scott from Trimble, and this week we're going to talk to their main competitor here in the US, Topcon. I have Nick Martin from Topcon here with us today. He is a district sales manager, and he's here to give us some more insights into what 2D machine control is, how it differentiates from 3D or GPS machine control, and just kind of what to expect as you start getting into machine control in general. But before we get into that, I want to take a second to tell you about the sponsor of this video, Chevron Lubricants. Protecting your diesel engine and its exhaust aftertreatment system has traditionally been seen as an either-or proposition when it comes to choosing the engine oil that's going to protect your system. And that's exactly why Chevron spent more than a decade of R&D work developing a no-compromise formulation. Now, I don't have to tell you why a clogged DPF is bad news, but here's the real kick in the pants. 90% of that ash clogging up your DPF and then upping your fuel and maintenance costs, it comes from your engine oil. You might be thinking, why don't they make an engine oil with less ash in it then? You'll be happy to learn that Chevron agrees with you. They've developed a new ultra-low ash diesel engine oil that is specifically designed to combat DPF ash clogging. Delo 600 ADF with OmniMax technology cuts sulfate ash by 60%, radically reducing the rate of DPF clogging and extending the DPF service life by 2.5 times. Before you had to choose between protecting your engine or your aftertreatment system. Now you don't. Delo 600 ADF with OmniMax technology. It's time to kick some ash. So Nick, thanks for being with us today on the show. I really appreciate you taking your time out of your day.
Yeah, thanks for having me.
So just so that the viewers kind of know who you are, would you mind giving a proper introduction and letting us know a little bit of what you do through Topcon?
Yeah, absolutely. I'm Nick Martin. I'm a district sales manager with Topcon Positioning Systems. I live in the Midwest and manage a territory for all things Topcon for construction and engineering throughout all the Midwest here. And I've got a lifelong of construction experience. I'm a construction engineer by training and through school. I started working in the construction industry when I was 18 years old, and that was just by happen chance where here's a job that pays about as much as anything else that I could find as an 18-year-old, and found out prevailing wage jobs and said, here we go. Here's a great opportunity to make some money. And that ended up sticking, and throughout working for contractors and through manufacturers, all for the construction space, I've had a full career all in the construction industry. And it's been both with buildings that are going up and job sites that are going horizontally, infrastructure projects, you name it. I've touched on a little bit of every aspect of the business.
So when it comes to the 2D and even the 3D systems, I would assume, especially with your position within Topcon, you're pretty well versed on these systems.
I hope so, yes.
Well, my first question is really in layman's terms for the viewers. Can you explain what a 2D machine control system is and really how it differentiates from 3D? And just so the viewers know, when we talk about a 3D system, we're really talking about what everyone calls GPS, correct?
Yeah, it's either GPS where we're using the satellites in the sky, or we're using, say, an instrument like a robotic total station to position ourselves locally on the job site.
And so how does a 2D system differentiate not only in its function, but also when it comes to, and we'll get into all of the details, but cost and everything, but really from a functional standpoint, how does 2D really differentiate from a 3D system?
Well, let's start here real quick too. Let's make sure we're all on the same page with what machine control is. When we say in general machine control in a construction environment, we're really just talking about systems and in our instance technologies that take all the plans and specifications and the differing job site conditions, and we put that information in the hands of the operator. Okay, so that's all that we're doing when we're talking about machine control in general, is just how do we take all the information required to build a construction project per plans and specifications and deliver that in an efficient and meaningful way to the individual or professional who's running that piece of equipment. Now, when we're talking about 2D versus 3D, it can really be isolated as simple as this. 2D machine control is where we're monitoring the cutting edge of whatever machine you're using relative to itself. So what do I mean by that? Is where if I say, here is my grade on a job site, I can bench in with a 2D system and say use a rotating laser, for example, which is a very common application, and go anywhere on that job site where my instruments can talk to each other and grade a level pad, for example. Okay. Now, the difference between doing that application in a 2D environment and a 3D environment is we take the location of the machine on the project, in the world, say, you name it, and we add that into the equation. So not only do I know that my pad has to be level right here, but I know that that pad has to go 30 feet over and 40 feet up, and it has to be oriented at 30 degrees north, for example. And all that positioning information plus the information of the geometry of what we're building is what makes a system a 3D system.
So to kind of summarize that just a little bit and distill it down even more, with a 2D system, the machine is really only concerned with where the bucket or the blade tip is in relation to a said benchmark, whether that's a laser or something that you've benchmarked off of the ground using that cutting edge. Versus with a 3D system, you really have the whole site picture, and the machine knows where it is and knows what needs to happen in that spot on the job. Is that kind of another way of putting all of that?
Well, here, let's take a common machine, for example. Okay, say an excavator, right? We can do a lot of different things with an excavator. We can go put sensors, they're called IMUs, or inertial measurement units, on the body of the machine, on the boom of the machine, the stick of the machine, and the bucket of the machine. And with those sensors, plus computers and software, we can always monitor what that machine is doing as it moves and rotates. So say if the tracks are stationary and the body is rotating and the boom's going up, stick's going out, bucket's curling, with those sensors, we always know what that cutting edge is doing relative to what those tracks are doing. Okay, so say if you go touch down at the benchmark for a flat pad, and as long as you don't move your tracks, the sensors can always reference that benchmark around. Now, with that same excavator, what we would do is we would take those same sensors and same computers and very commonly add antennas on it. And with those antennas, we're accessing the satellites in the sky that everybody who's using GPS in your phones, navigation for marine, military, we're all accessing that same information. But that puts that excavator exactly where it is in real time on the job site. And that's the difference there between a 2D and a 3D machine.
Perfect. That's a great explanation. Thank you. So what is a real life scenario where you would use, and I know there are a ton of them from my experience in the field, but what are some just quick examples of some real world scenarios that a contractor would really benefit from a 2D system without stepping all the way into a 3D system?
Let's say that I'm building basements and they're relatively simple designs, say, easy residential kind of geometry where they're just squares essentially, or rectangles. Well, I can simply go find the building corners without much help in that instance. But with a 2D machine control system, we're able to go and take that operation of knowing where the finished grade or the grade for the bottom of the basement is right there, without having to do things like climb out of the cab, get a rotating laser and a grade rod, and walk down inside of an exposed pit. So that's an example of where, for relatively low cost, you can introduce machine control, and at a basic learning level too, or an opportunity to start understanding how the sensors are interacting with the machines and how that relates to grade and productivity on the job site. And you can use that technology and those tools in order to go out and really efficiently and very accurately grade a basement pad or a footing pad, for example. Or if you're building patios, you can use 2D to say, here's my flat pad, or take it a step further and say, I've got to drain 1-2% so water can go. You can add all those factors into the equation with 2D machine control. Another one we find very commonly is we're seeing a lot of large warehouses that are being built all over the country. And they'll build the warehouse and then they'll go grade the inside of that warehouse. But it's just a flat grade. They're just as flat can be. And in that aspect, you can take very commonly, you find skid steers with grading or attachments on them, plus a rotating laser, and you can, with an operator and a rotating laser and a 2D machine control system, very quickly and efficiently go grade your finished subrock right to spec without any other assistance on the job site. You don't need somebody walking around outside of the machine. You don't need surveyors coming in and telling you where everything goes. You just got the machine, a rotating laser, and a 2D system, and you can go get your job done.
I tell you, that's my first real experience with 2D machine control. You know, I'm like most guys in the industry. I was very well versed in GPS because I had been with larger companies that used that technology, but I wasn't as familiar with the 2D systems. And what really proved it to me was the first time I got in a skid with a grade box that was equipped with the 2D system and a laser. And that's where I went, oh, I understand the power of this now, because there is no guesswork. We are exactly to grade, accurate, laser accurate. You know, that was exciting to me to see that sort of technology available for a skid steer. So
yeah. You know, it's so funny that you say that, because I had my own aha moment back in college when we were first, we were learning at that point just Survey 101 on the construction side, essentially. And we were running traverses around a building, and I hadn't totally figured out what the point of this operation was, at least to the point where I fully comprehended it. And so, but somewhere around walking around the technology center with an automatic level, taking manual shots on a grade rod and writing them down in the field notebook, it started to dawn on me, oh, we have to match this point to the start, and then that way we can daisy chain all of our elevations around the job site. And I was like, yeah, that makes sense how we're building jobs in a construction world. Absolutely.
Yeah, it is interesting how you just have these aha moments that pop up, and it's like, I get it now. I totally get it.
And once you have that aha moment, everything else kind of falls into place. Yep, that makes sense, and I can do that, and that one makes sense too. It's a liberating feeling, that's for sure.
It is, absolutely. So my next question for you would be, if I'm a contractor that has zero experience with machine control, I don't know where to start, what really is the first step towards working to even asking questions to someone who is knowledgeable about machine control?
I would say the first thing you could do would be just look around and see who's using instruments on the construction site already, or around town, around the county, around the state as you drive around. Where do you see these applications going on? And then, just a quick Google search, but there's local support and professionals all over the country, all over the world, really. And so beyond that, that's the best place to start. Is you find a sales professional, you find a company that you want to get to know and start working with, because in this space, that's going to be critical. It's as much of what you're doing and what you're using as who you're partnering with as well. And so involving the local companies that sell, that service, that really live in this environment with machine control and construction positioning and location every day, that's going to be your best asset as you figure out what systems are right for me, what systems are not right for me. And even beyond that, it's okay, now I've invested in 2D machine control. It's going to take some training, and you're going to want to welcome the training as well, because that's the case of an ounce of prevention is worth a pound of cure. If you take the time to really familiarize yourself with your investment, to bring on the help and the training from people who do this every day on job sites all across your city, your state, North America, that's what's really going to take the learning curve. And what I find some of the kind of hesitancy to getting into this environment is just the fear of the unknown. I don't understand fully how this technology works. I don't understand, or I don't know if we'll be able to comprehend it. I'm worried about the risk if we buy this and we're not able to understand it. Will it just sit on the shelf and collect dust in our warehouse, et cetera? And so really partnering with somebody who takes the time to get to know your business and your application and does the right job of marrying the right products and solutions to what you're doing and will train and support you and really be there as a partner with you as you go along this technology journey. That's probably the best thing that you could do.
And you just kind of touched upon a point that I hadn't even thought about bringing up until just now, and to kind of piggyback off of what you just said. So a great spot to just start is one of your local equipment dealers. So most dealerships at this stage in the game are pretty familiar with machine control, whether it's 2D or 3D. They at least know what it is, and they have access to people that if they don't work with it at the local level, they at least have access to people within Topcon or Trimble or Leica, whichever one you're working with. They can reach out to experts who know the systems. They can bring those people in and help train you. And then another option that's available in a lot of places is they will come out and demo a unit and allow you to see it on the ground working on a machine on your job site. So your local dealership is really a good starting place to where at least some phone calls can be made to get you in touch with the right people that know what they're talking about.
Yep, absolutely. They're an excellent resource. And, just a quick Google search with, machine control companies in Name Your City, America. And that'll point you in the right direction a little bit. If you want to, Brian, you can give everybody my phone number and I'll do my best to personally guide them in the right direction. It's hard to answer it specifically because it varies by market on where some of the better resources are. A lot of places it is your John Deere dealer. It's your local Takeuchi house, for example, that's servicing and supporting your fleet already. They are very well up to speed. They're well educated in what the products would do. Other places, it's still the kind of owner operator survey shop that has got 20 years in machine control, and they can be excellent resources as well. And even more, a lot of the times it kind of turns into all of the above also. It's just the more that we progress in the construction industry towards embracing and investing in technology and utilizing it on a bigger scale, the more people are getting involved with it too. And so as we go along, you're going to see more people that are selling the equipment are going to be invested to a point where they can really take on the challenging applications with you. And you'll still have all these other companies that are out there that have been really just focused on the surveying and technology aspect of the business for a long time now, and they're going to be there supporting and helping everybody along as well.
Generally speaking, is a dealer required to install one of these systems, or is this something that I can go on the internet as an owner operator and throw my machine in the shop and do it all myself?
I would say if this is your first experience into a 2D machine control application, then you're going to want a dealer there with you on the machine doing the installation of the components, making sure that all the systems are working properly, that everything's simply got like the most up-to-date software and firmware versions on it so that you're running the most latest and greatest versions of the system on there. Now, it's kind of like anything, that it's not rocket science to go out and install a machine control system on a dozer or a motor grader or an excavator, but you do have to know what you're doing. And it's like anything in the construction environment and in life, really, is that if you know what you're doing with it and you feel comfortable, then yeah, you can absolutely install and calibrate and set up your own machines. And we have plenty of customers that have evolved into that space where we started out with a 2D system and they invested in that and they saw value in the 2D system. And so they bought another 2D system and then a 3D system. And then they hired what's commonly called a point man. in a construction company, where it's just an individual who's responsible for managing all the positioning and layout and all those aspects of the work to be done with the companies. And in a lot of cases, we've worked with those individuals and then sometimes the mechanics that people have in the shop. And, we train them on how to install and set it up and support it themselves. And so we have customers that buy systems from us and they perform their own installs and they're doing a lot of their own support. But really what you see is you build and evolve into that. So if you're getting into this space as a first time customer, a first time investor, this is your first time jumping into a 2D or even a 3D environment, there's enough to focus on, in my opinion, with learning the machine control system, how that interacts with the machine, how the operator is going to use it, what the foreman on the job site is going to change, day to day operationally now that they have these tools to assist with what they're doing. That's a great place to start. Get comfortable with using it. Make sure you're fully comfortable with the performance of the systems and that you know that what you're doing is the right thing and you don't need your help or anybody's help running your investment right now. And once you feel comfortable with that after a week, a month, a year, whatever that is, then a good next step is to say, okay, maybe we can take this on and put these sensors and measure them up ourselves.
And I'll say too, it's also it's worth having the hand holding on the first go around for the simple fact that with 2D and 3D systems, most people can fumble their way through it for the most part as far as usability, figuring out how to set a slope or a cross slope and then going with that. But really, the power comes from these other things the system can do that aren't necessarily obvious to the user right off the bat. And to have an expert there that knows the system in and out and can guide you and say, hey, you could do it that way, but here's a way that's 10 times easier if you just go to this screen here. Having that hand holding can actually, it's worth the investment because in the long run, it will save you a phenomenal amount of time and heartache on the job trying to figure it out yourself.
Yep, that's exactly right. And then why we always say it's worth the training up front, because a lot of people think that GPS stands for God's positioning system. And that's not the case, because you can still get this stuff wrong. You can go put an offset in the control box, and if you tell it a foot high on the offset, it's no different than if you wrote your reference a foot high and were manually traversing a job site. If you give it bad information that you're working off of and you think that the technology is foolproof, you're going to get into trouble there too. And so that's a lot of what the trainings do. It's not only what's the system doing, but okay, now I'm out on the job site and I'm going live. How do I still perform double checks on a construction project? Because as everybody knows already, it's really expensive to build things twice, and you generally don't have enough profit margin for that.
So my next question is, we've kind of covered what 2D systems are, where you can go to have the conversation. Why should I do this as a contractor? If let's say I'm one of these guys that's been in the industry for 30 years, I can run a dozer and make that parking lot look like glass when I'm done. Why do I need to go invest, call it around $30,000, which I don't know your numbers. We'll talk about that in a second, but why should I go invest $30,000 in a 2D system when I'm perfectly capable of doing it myself?
By no means does technology take the professional operator out of the equation. The ability to go out and control a dozer and craft the earth to paint the picture out there, we're assisting with where everything goes, right? So we're just changing that datum input from grade stakes that are out on the job site, blue bangers that are out on a road, and we're just translating that into the cab of the machine. It still takes a professional hand in order to go safely, productively build these job sites. So the machine control systems, by no means, it's a tool to support the professional operator. We always kind of say people would come to us and think this can make a bad operator good or great, and that's not the case. We can take a novice operator and really make them more efficient and really make them better at their job. And as an owner of a company, we can kind of manage the risk end of it too, right there. But yeah, the role of the professional operator is almost even more so amplified when you're using the technologies on there, and it's a critical piece to the construction project. So as a professional contractor, something that we find, or that I find, that's kind of a constant theme around the construction industry of what makes contractors successful year to year, generation to generation, is really three things. It's that they perform the work safely, because if you're not performing, if you can't send employees and workers home in as good a shape or better shape than when they came in at the beginning of the day, that's not right, and it's not sustainable and can be very expensive, as everybody knows. The other thing is to perform quality work, and that goes hand in hand. It's obvious, but if I'm not building the job that I said I was going to build, if I'm not doing a good job, if I'm grading too high consistently, then that is not sustainable either. And then the third thing about that is productivity, right? And those things all kind of fall in line. Productivity is worthless if you're not doing a great job at what you're doing, and quality is worthless if you can't perform that safely. Okay, so how do we assist in those three pillars that are pretty common in the construction environment? Say that you're installing utilities underground. That's trench work, and anybody that's out there will, that understands that trench work can be dangerous, and there's a lot of regulations that, even as much as I've been involved in the construction industry, I still get kind of glossy-eyed when I start going down that rabbit hole of everything that's required to do trench work safely and properly. Now, let's say that we're doing rough grading down in a trench, and you have to have a person down into that trench to relay that grade back up to the operator in an efficient manner, which means that you physically have a person that's down inside of the trench, right? That's an opportunity, or that's a risk. That's an opportunity to get hurt. So simply by adding a 2D or 3D system, immediately we can take that individual out of the hole. We can get them into a safer spot. You just don't need it, because we're monitoring from the cab of the machine what that cutting edge of the bucket is doing. Okay, so then you can take the same safety scenario and say you've got a dozer operator that's kind of running around on themselves, and they're just doing simple pad grading, and they're doing spot checks where they've got to get out of the machine, walk to where they're going, check, maybe paint on the ground, -2, or cut 2 here, +2 there, get back into the cab. Well, any safety director that's worth his or her salt will tell you that every time you climb on something, you're introducing an opportunity for another hazard right there. Slips, trips, and falls, ladders, stairs, those are all key points where it's driven from data. That's where a lot of injuries or reportable incidences happen on a construction site. So if we can simply prevent the operator of the machine from having to crawl up and down on that dozer, one slip and you've paid for a 2D system, or probably a 3D system, pretty easily out there. So that's the ROI from a safety aspect. Now, the quality aspect, by taking the plans, and in a lot of instances, say we're in a 3D environment where we're going in real time on job sites anymore, from design in the office, an engineering firm, the construction company's design teams, you're taking the design from the office out to the field, and you're kind of building things in real time. So it's very common to finish the design of a portion of a job site in the morning and transmit that data out to a machine in the afternoon. So what we can do is very efficiently, from the computer with a click of a button, say, upload this plan set to this machine right here. And that's all managed right from the people who are doing the design. And then you don't have this instance of I printed off the plans, where the foreman on the job site printed off a plan set, and then they got shuffled or rained on, or we got the wrong things, we're looking at the wrong place. So you're really you're streamlining the data flow from a design environment or from a specification environment out to the field, right? And you're putting that information in real time in the operator's hands. And you're doing it with tolerances that it's hard to replicate outside of the technologies that we're putting on the machines right now. And then leads into the productivity statement. So all those things are they're all intertwined, right? Safety and quality all lead to productivity. But it's just simply put, and you can find YouTube videos, you can see around job sites, talk in conferences, see seminars of, let's take a simple application and compare head to head a conventional grading operation versus a machine control grading operation. And just the fact that we don't have to stop and reference grade stakes and wait for somebody with a grade rod and a rotating laser to go in and give us our benchmarks or our grade references as we're going. We can just keep working. So if you have all that information in the cab, you never have to stop that machine from productivity in order to get your positioning information. And then you you reduce the risk of, okay, I dug a little bit too much. Now I've got to go put a little bit back, right? Since you've got the information at your fingertips and the guesswork is really taken out of it as far as where finished grade goes, now it's just, I'm digging and there's my grade and we're done. Not we're digging and we've got to stop to evaluate and then dig again and fix, right?
So it's funny that you bring this example up. I actually last month was out in Minnesota working with a contractor friend of mine, and it's all a young crew. So we're getting into this interesting area where there's this generational gap within the trades, to where you have the old guys who, screw computers, I don't want that stuff on my machine. But then you have this younger generation that's all they've ever known. And in this particular crew, they were young guys that had been around machine control. And when I was explaining to the owner the power of machine control, he had never been around an application where someone was actually checking grade. And I said, are you not familiar with how this was normally done? He goes, no. I said, normally you have a grade checker and he goes out and sprays marks out 50 feet in front of you, and then you have one or two passes to hit those marks. And then he has to recheck them, and hopefully you hit your marks. If you're a good dozer operator, you hit your marks and you can move forward. If not, you got to do it again. And he just looked at me and he goes, you've got to be kidding me. But it's interesting because there's still a lot of contractors out there in the industry that are using that. But when you really put it side by side with the click of a button, I've input my slope, and we can just track forward and carry that grade, whether we're using a laser system for 2D or we're using a full-blown 3D system and it's carrying that grade. You've totally eliminated, first of all, the paying the guy to stand there and check grade all day. But secondly, you're eliminating that entire length of time that you're waiting for someone to go out there and take those measurements and then communicate them back to you. And when you really put those side by side, you start to see how kind of really archaic the old system is becoming compared to these new systems.
It's funny you say that with the operator and the person running. One of the first things that I was introduced to in the civil construction environment as an intern was how to put in blue tops, or being a runner out on the job site. And I was the lucky one to draw the Western Texas straw in the middle of summer. And I was even luckier to draw the operator who thought that it was funny to go pop all the blue tops out as I would run around, because he enjoyed watching me run around the job site all day long putting in the blue tops. And he was an excellent. He's as good of a motor grader operator as I've ever come across in my life. And I figured out really quickly that, you could shave the top off of this if you really wanted to. Yep. So maybe for that instance, I would have personally invested in machine control just to get out of the sun.
So it's worth it to be done with it.
That's right. Yep.
So this is a question I actually discussed with Trimble. I'd like to cover it with you as well, because I know you guys have probably done your own studies. Roughly, and I know there's going to be a lot of variability, roughly what are you looking at for a payback on one of these? Let's stick with 2D systems, because I think the majority of guys aren't familiar with those. On a 2D system, one of your more complex, your spendier models, roughly what do you think the payback would be on something like that?
When we're talking about 2D systems, you're in general, you're looking at an investment from $10,000, could be up to $20,000, $25,000. And that just kind of depends on your machines, your applications. Are you taking rotating lasers into the equation, et cetera? There's a lot of factors involved in that. As far as a payback, I can tell you there's a couple of things here that we could say from data that kind of hint towards the value of these systems. Number one, we've consistently seen an increase in adoption of 2D and 3D machine control throughout the construction industry for years, throughout time. You've seen an uphill trajectory of number of people utilizing these technologies. So the very fact that companies keep purchasing and investing in these systems and technologies tells you that they are valuable and they do pay off, or else you wouldn't see them in a competitive capitalist society. Okay. Now, as far as what you can experience or expect as far as a payback on your system, it's truly going to vary by what you do and how much you use it and the kind of work you take on and your labor rates, your material cost by region. But it's not uncommon for somebody to invest in a 2D system and have that already pay for itself on the very first job site that they put that on. It's even more common that they pay for that system within the first year of owning it. And you very rarely would see, even in terms of talking with owners and how they think, that the amortization rate or time period for the technology on the machine is less than 2 years easily. And it's typically more in that 6-month, even project time scale anymore.
And that's one of the things that I do between talking with you guys here at Topcon and then last week with Trimble. One of the things I want to convey to most of the viewers is that fear of the unknown factor that you were talking about. This is going to be a lot of money, and really, how much am I going to save? And I don't think a lot of guys really comprehend, between time, between manpower, between material costs, these systems pay for themselves really quickly. And to the point that I was even wrong with my answer. The guy from Trimble last week corrected me because my guess was within a year, and he said exactly what you did. Most of the time it's within one job. And to me, that even blows my mind that it's that quick and it has that big of an impact.
Yep. Well, there's a number of different ways that you can, with just simple math, right? Addition and subtraction and maybe some multiplication and division, and you can go and quickly figure out on your project and in your company, what are these going to do? And this is kind of what we were talking about earlier, is doing your homework will all kind of lead to this end. But if I just say, I can be 10% more efficient with this grading operation, then you just take your operated hours, your crew cost, and take that times 0.9, and you'll get your expected ROI based on your volume right there. If you are currently paying survey cost for people to come out and give you multiple, benchmarks on the job site, and to give you offsets of building corners, for example, to put grade stakes out, you can just really quickly take a look at what you've spent in surveying cost over the last year, or even just think on a specific job site, okay, here's where I'm spending money on these professional services right now. And by taking a machine control system on I would immediately eliminate that need for that additional input of support, or where does stuff go on the job site, right? So that's a really quickly linear way of, I buy this and then I don't have to spend this on these things right now. You can look at it in terms of your yields. If I'm consistently having to cut a 1/4 inch too low to make sure that my 4 inches of rock is 4 inches, cannot be less than, just that simple 1/4 inch of rock over 20,000 square feet that you could be saving.
Yeah, it adds up quick.
Your yields all up. And in reality, we're taking all of those factors, and that's what's all coming together. And so it's, if people were to just trust me, I would just say it's absolutely valuable. You should buy it right now. No questions asked. But I don't want them to do that. Take a look at your own operations. And that's where, since we all live and breathe in this environment too, we can kind of help out with, here's some expected, or you can grab references from people and say, how's this worked out for some other people you've worked with, right? There's a lot of ways to quantify the decision here.
So my last big question relating to all of this, is you guys have a pretty close working relationship with John Deere and Komatsu. I assume that you guys are not exclusive, that you guys work with all manufacturers. Is that correct?
Yep, absolutely. So at Topcon, really what we want to do is be the brains and the engine behind the positioning piece and the fine grading application portion of that, right? That's what we do really well. That's our passion, is just how do we build technologies that, in this conversation, for example, can support that dozer, right? Can support the operator, can support that grading crew. We don't want to do that for just one machine. We want to do that for all machines. We want to do that for concrete machines. We want to do that for asphalt pavers. We want to do it for excavators. We want to do it for mini excavators, you know? I mean, really, we want to be that positioning piece for somebody just out there with a shovel and a rake, whether it be a rotating laser. That aspect. So yeah, we partner very well with John Deere. We partner very well with Komatsu. We bring a lot of our experience and a lot of our technologies to the table there to help them with their grade management solutions that they're introducing into their equipment. But we don't want to just do that for a John Deere or Komatsu. We want to do that for everybody that's out.
For the industry overall.
Yep, because that just, if we just focus on here's what we're good at, then we're much better at that. And then we can come bring better solutions in the future a lot more efficiently.
So that kind of exhausts my questions about machine control in general. My last question for you is there anything new, exciting that's coming from Topcon that you are allowed to talk about?
Ooh, I don't know. Yeah, so here's kind of something that I was thinking about in the terms of all of this, right? And this is a little bit comes, I suppose, out of nostalgia from being in the construction environment for about, I don't want to date myself, but right around 20 years now, is that I personally have seen technology go from something that was very expensive, very complex, and only accessible to a very small portion of the construction environment. And in the short time period of my professional career even, I've seen this technology get exponentially easier and more user-friendly, and all the systems talk together a lot better. And the cost of investment has come down. The barrier to entry of I don't have to have, 30 years ago, a rotating laser was probably $10,000, and now they're under $1,000. You can get a really good, competent rotating laser. So that's where I see technology in general heading in this space. Is it's going to be easier to access. It's the barriers to entry are going to be less and less, and what that's going to do for everybody is not only is it going to be your billion-dollar huge high visibility road contracts that are out utilizing technology only on their motor graders, but everywhere you go, there's grading applications that are still done traditionally. And it's for a lot of the reasons that we were just talking about. The fear of the unknown, the cost to get into the business. That's where I see everything heading, is that it's going to be more accessible to more machinery. There's more people and company profiles that are going to be not only able to invest, but that the market conditions are going to demand that they invest in these technologies. And it's simply what we're doing at Topcon, and where we want to focus our attention is how do we make our technologies and our solutions more accessible to everybody in general. And so a lot of that means the continuation. We've pride ourselves on building things that are contractor specific right now, and how do we make our systems talk together seamlessly, and how do we build operator software that's, we call it Bubba proof sometimes, but that's in terms of what an operator thinks about. Let's not take surveying language and translate that into a machine control system. Let's use machine control terminology right there. And then it's just how much of the technology can I use to support all of my applications? So let's say that we're running what would be called an LPS, or a local positioning system, where we take total stations and we're guiding that. Okay, well, now I can take that total station, and if I'm guiding a grading blade on a skid steer in the morning, well, then why can't I take that total station and use that for building corner stakeouts in the afternoon? Okay. And so if I invest in a machine control technology, It's the same fundamental things that we're using for GPS surveying and layout on the job site. So how do I use all these technology pieces that I've invested in and take advantage of on every aspect of the job site to where I need to know where things go? And then I also see it being more accessible to all the different trades on the job sites too, because certain trades you see that are very far along with technology utilization and some are further behind. But in all aspects, it's a construction environment. It's not optional that we build things where they're supposed to go. It's dictated for a purpose. And so for that reason, we're just going to keep making things that are easier to use, that are more accessible, that are more versatile on the job site, things like that. But I can't tell you exactly what they'll be.
That's all right. I accept that.
Yeah.
I will say overall, it is a really exciting time to be in the construction industry. To just, for a long time, it was just the efficiency of the machines getting better and better. And we've kind of reached this new tier to where it's technology being introduced to machines and really taking that production and the efficiency to a whole other level. And the cool thing has been just how quickly that has happened. Like you just said, we're not that far off from GPS systems literally being only available to the top biggest companies out there that could afford to spend hundreds of thousands of dollars on these systems. And now it's gotten to the point where a guy that does driveways and small pond jobs can very easily get into one of these systems, whether it's 2D or 3D, for a relatively low investment and with a very quick payback. So it is a very exciting time to be in the industry.
Yeah, when I first started, you would see maybe a rotating laser for your average construction company. You would have one or two per company, and you would share that resource amongst the crews. Now, you almost have a rotating laser, not even per crew, but everybody has a rotating laser.
Per grade checker even.
Yeah, they all have, and that's where I see, take a total station, for example. Now, a company might have a few total stations, but there's no reason why, say a crew that's building culverts out on a job site. Well, every crew should have their own instruments that are helping them position and put everything into the right spot. So that's where everything is going. And instead of just having, this is our 3D grading dozer, well, every dozer can be a 3D grading dozer. Yeah. Yep. Every excavator can be a 3D excavator. So.
Well, Nick, I really appreciate your time today. I really appreciate all the information and kind of the breakdown of all of this into very easy to digest terms for everyone.
Yeah, I did my best. I hope I did okay.
No, you did fantastic. It was great. I really appreciate it, and hopefully we can do this again sometime in the near future. So thank you again to Nick and to Topcon for volunteering their time to come on the show today and actually spend some time with us, really drilling down into what 2D machine control is and how it differentiates from traditional GPS systems and why it's beneficial to the end user. I'm going to be honest, I nerd out over these conversations. I really enjoy the technology side, and I really like seeing it applied to the construction industry and just how big of an impact it's having, not only on production, but also the results, the actual accuracy of the job at completion. It's just really amazing to see the technology work. So I do realize there was some overlapping in questions from last week's conversation. I did do that intentionally just because, as you guys could see, there was quite a bit of difference between the answers and the explanations given by the two guys that we had on the show. And I think ultimately that benefits you as the viewer to get those different perspectives and those different explanations to help more people understand and maybe give you a little more in-depth explanation on some of this stuff. So as always, I hope this has been helpful to all of you guys. Absolutely feel free to comment below if you have some commentary or you have questions on machine control, and we'll be happy to get back with you. And we'll catch you guys on the next episode of The Dirt.